In this video, we're going to be looking at points of intersection between two straight lines, right? So the way that it's going to work is we're still working on our Cartesian plane, right? Even though sometimes in the question, you're not actually going to get a Cartesian plane, but just for illustration purposes, the two graphs, the two straight lines that we're focusing on are on a Cartesian plane. And let's say, for example, we start off with this line over here, right? And then we also have a second line. Maybe let's just say it's somewhere over there as well. All right, let's put this one here. Okay, so the first line has, because it's a straight line, it follows the equation y is equal to mx plus c, right? We're going to call this y1. The second line, because it also has the equation y is equal to mx plus c, we're going to call this y2, right? Y is equal to some mx plus c value, right? So both of them have y is equal to mx plus c equations. Now, the point that we're focusing on, the point of intersection, is this point. A point of intersection is a point where two graphs cross one another. They basically meet at the exact same point. That means at this point where they meet, they have the same x value, and both graphs have the same y value, right? So essentially what we're asking when we're trying to find the point of intersection is, okay, what is the point where the x value and the y value of the two graphs are exactly the same? So let's look at an example of this just to illustrate this a little bit better. So let's just say, for example, we have two equations. The first equation is, let's just turn this into black. All right, so that's going to be y is equal to 2x minus 1. That's your first equation. The second equation is y is equal to negative x plus 2, right? So these are two straight lines. They follow the equation, they follow the formula, y is equal to mx plus c. So if we're trying to find the point of intersection between these two lines, like what we're saying, right, we have these lines and we're looking for the point where the x is the same and the y is the same for both of these graphs, right? So we can apply the same x and y for both graphs. If you have two equations or two functions with which each have two unknowns and the unknown values apply for each one, meaning this graph has an unknown x, this function has an unknown x and an unknown y. Same thing with this one, unknown y, unknown x. If those two values are exactly the same, meaning, for example, if this x is equal to 1, then that x would also be equal to 1, right? They have the same x value, those two separate equations. It means this is what we call a simultaneous equation. Basically, I say all of those words to say, in order for you to find the point of intersection, solve the simultaneous equation of the two functions that you're focusing on, right? So essentially, so what we're going to do is I'm going to draw a graph. I'm going to sketch these two graphs, and then we're going to solve for the simultaneous equation and see if it makes sense, right? So our equation looks something like this, or these are graphs, right? So the first graph, like we said, they're both straight lines, right? So that's your y, that's your x. All right, so your first graph has a y-intercept -1, so we're going to put it somewhere over here. It has gradient +2. Maybe let's say, for example, we're looking for a second point. So maybe let's say, how about the x-axis? How about the x-intercept, right? So x-intercept is when y is equal to 0. So that's going to be 2x minus 1. Take it to that side, it becomes x is equal to +1/2. Basically, I was trying to solve for the x-intercept, which is at 1/2. So this graph does something like this. All right, crosses at x is equal to 1/2, y is equal to -1. All right, so that's your first graph. We know what that looks like. Your second graph has the y-intercept +2. So maybe let's put this one somewhere here. That's +2. Your x-intercept, right? So that's your y-intercept. To get your x-intercept, you say, okay, y is equal to 0. So that's going to be 0 is equal to negative x plus 2, which means x is equal to +2. So that means it's somewhere, maybe let's put this one somewhere there. So your graph looks like this. Horrible graph, but it's fine. All right. Okay, cool. So we're looking for this point. So this is our point of intersection. We're saying, okay, at this point, what is the x value and what is the y value at the point where the two meet, right? You don't really need to understand what it looks like on the graph, right? So we're just doing this just to explain and just to see if our answer makes sense. But all you need to know is, okay, I've got these two equations. Y is equal to 2x minus 1 and y is equal to negative x plus 2. All you need to do from this point is solve the simultaneous equation. However method you want to use is fine, but because we're also going to be working with the same kind of approach when it comes to circles, right? I want to use a method that I can use across the board, which is going to be substitution, right? So in this case, we're going to say, okay, this is the y for this equation, right? So for equation 1, we have y is equal to this. For equation 2, we're going to say, okay, since the y is exactly the same, we're going to substitute this y into this equation, right? Remember, this y is actually negative x plus 2. So that means, or actually, if just to explain it better, the first y is the same as the second y. The first y has the equation 2x minus 1. The second y has the equation negative x plus 2. So we can solve like this, right? So just to solve this, it becomes, put all the x's to the left-hand side. So your negative x becomes positive x. That's 2x plus x. This negative 1 becomes positive 1 on that side. That's positive 2 plus 1. So that's 3x is equal to 3. Divide both sides by 3 to cancel it on this side. And it becomes x is equal to positive 1. So that means, so we can kind of see that that makes sense, right? Because this was a half. This point over here was positive 2. It makes sense that this x-intercept is at the point x is equal to positive 1. All right. And then remember, for simultaneous equations, you're always solving for two, at least when you've got two unknowns, two equations, two unknowns. You remember you have you have a second y that you need to solve for. And that y, to get that y, we said your y is equal to, you can pick, if we used, actually you can pick whichever one of the two, it should give you the same answer. Negative x plus 2, this should be equal to negative x is positive 1. So that's going to be negative of positive 1. And then that's plus 2. Negative 1 plus 2 gives you positive 1. And that's your y value. So that means this y value over here is positive 1. So essentially, right, if you forget all the things that I said, all the things that I drew in this video, just remember, if you're looking for the point of intersection between two lines, you solve the equation, you solve the simultaneous equation between those two lines. That's going to apply for straight lines. For a line, the intersection between lines and circles, essentially it applies across the board. All right, so before we just end, let's just go through a second example, example number 2. Example number 2 says, right, so we have equation 3y plus 2x is equal to 5. And the second equation, 4 minus 2y is equal to x. And you're looking for the coordinates of your intersection, point of intersection, right? So this one is not as clean as this one, because for this one, we could just take your y here and then just equate the two. In this case, we might need to do a little bit more work. However, right, you always look for the easiest way to solve your simultaneous equation. By that, I mean, right, remember we're using substitution. So the thing that's easiest to substitute, that's the route we take. So in this equation, I already have an x expression. So I can take this x expression and put it into that term over there. So if this is my equation 1 and that's my equation 2, that means equation 1 becomes 3y plus, instead of having 2 times x, we now substitute the x expression into that term. So that becomes 2 multiplied by the x expression, which is 4 minus 2y. That's equal to 5. So now we have an equation with only y's, which is perfect, right? So because now we can solve for y. So we're going to simplify. So that becomes 3y plus 2 times 4 is 8. Positive 2 times negative 2y becomes negative 4y. That's equal to 5. And then 3y, we're going to group our like terms. So 3y minus 4y gives you negative y plus 8 is equal to 5. I usually like my unknown value to be positive. So if I have negative y, I'm going to take it to the other side so that it becomes positive y. But now I need the 5 to go to the other side. So that becomes positive 8. Remember when the 5 was positive on the right-hand side. So when you bring it to the left-hand side, it becomes negative 5. So y is equal to 8 minus 5, which is equal to 3. Perfect. So that's your y coordinate. So in order for us to get the x coordinate, we then go to equation 2, the other equation that we didn't use, and we say, okay, the equation was x is equal to 4 minus 2y. And that's equal to 4 minus 2 multiplied by 3, which is 4 minus 6, and that gives you negative 2. You can always, the good thing about simultaneous equations, you can always plug them back into the initial equation just to check if your answer was correct. So for example, I know that my y is equal to 3, my x is equal to negative 2, I think. Yes. All right. You can always plug them into both equations. So 3 multiplied by y, which is 3, plus 2 multiplied by x, which is negative 2. What answer does that give you? 9 minus 4. 9 minus 4 does equal to 5. Perfect. That's correct. Move on to the second one. 4 minus 2y. Now y is 3. So 4 minus 6 does give you x. But we expected that because we used that for the second equation. So that does give you negative 2. But if both of these are looking correct, it means you didn't make a mistake. These are probably the checks that you want to make in your exam, just to give yourself an assurance that, okay, if this is a 3-mark question, you have those 3 marks in the bag. You can move on to the next thing. But yeah, for now, the key takeaway in this video is, in order for you to get the point of intersection, you equate the two lines, or at least you calculate the simultaneous equation between the two lines that are intersecting. All right, I hope that made sense, and I will see you in the next video.